longitude and time differences. So once again, reminding ourselves what's on the formula sheet, we're going to be using this bit of information down here for time differences. So time differences. The time of day is dependent on the rotation of the Earth about the north-south axis. A complete revolution, 360 degrees in longitude, of the Earth takes around 24 hours. So how many degrees is that per hour? So we can write the statement 24 hours equals 360 degrees. So we divide both sides by 24 to find what happens in 1 hour. And we get that 1 hour is equal to 15 degrees. So that's going to help us with being able to work out the time differences using longitude. Remember, this is on the formula sheet, so you don't need to remember it. So places on the Earth with the same longitude will have the same local time, unless they are in different time zones. So when the sun shines directly on a meridian of longitude, it is 12 noon, and at all places along that meridian. On the other side of the world, it is midnight along the opposite meridian. So for example, when it is noon at 120 degrees east meridian, it is midnight on the 60 degrees west meridian. Local time. Local times around the world are measured relative to the time along the prime meridian, 0 degrees. This is called the Greenwich Mean Time, or Coordinated Universal Time. Now remembering that every hour is 15 degrees, so if you're moving along the meridians of longitude, then each 15 degrees along is going to be an extra hour. And that's why we break up the 180 degrees east and 180 degrees west. It breaks up into 24 hours, and you can see that's 15 degrees. The gaps between along here matches up to the gaps of an hour along here for the time zones. Places east of the prime meridian are ahead of Greenwich Mean Time, and places west are behind. Finding the time difference and local time. Auckland is located at 37 degrees south, 175 degrees east, and Wollongong is located at 35 degrees south and 150 degrees east. We're not going to worry about the time zones, we're just going to look at the time difference using the information that 1 hour equals 15 degrees. So, to calculate the difference, we need to find the angular distance between the longitudes, because that's what makes the difference in time. So, we have 175 degrees east for Auckland and 150 degrees east for Wollongong. So the angular distance will be 175, take away 150, which is 25 degrees. To convert this into time, we divide the 25 divided by 15, and we get 1.6 recurring. Now we want to convert this into hours and minutes, so remembering to press your degrees button on the calculator, and you're going to get the answer to be 1 hour and 40 minutes. Okay, when we're doing questions looking at the time difference between places, I like to write it up. So I have Auckland, and I've written Auckland to the right because that is further to the right than Wollongong, and the time, the difference in time is 1 hour and 40 minutes, which we just worked out. So that way you know if you're going right, you're adding, and you're going left, you're subtracting. So the first question says that what is the time in Auckland if it's 2 p.m. in Wollongong? So I write the 2 p.m. under the Wollongong because that's the time that we have. So we're going to add 1 hour and 40 minutes to 2 p.m. So the answer is that it's going to be 3:40 p.m. in Auckland. Okay, do you see how by setting it up like that it's quite easy to do the questions? So the next one says, what is the time in Wollongong if it's 9 a.m. in Auckland? So we're going to start on this side at 9 a.m. So this time we're going to subtract the 1 hour and 40 minutes. So that's going to mean that it was 7:20 and it's still going to be a.m. Okay, so just one method. You can do it any way you like. You might just be able to do it in your head if you like, but I like to write down Wollongong, Auckland. Make sure that Auckland's on the right because it's further east, so that means it's ahead of time, and then put Wollongong on the left. You put your time difference that you'd already worked out, and then you can just put underneath the different amounts you've got, it's quite easy to know whether to add or subtract. Okay, determining times for cities in different countries in related travel. So this is where we're going to look at time difference, and then we're going to look at travel on top of that. So Chicago has a longitude of 88 degrees west and Seoul has a longitude of 127 degrees east. So what is the time difference? Okay, so because one is west and one is east, we're going to have to add these two together to get the time difference. And we get 215 degrees. Now we need to convert that into time. So 215 divided by 15. So that'll put into hours for us. And we get 14.3 reoccurring, and now we use the degrees minutes button to put it into hours and minutes. So that becomes 14 hours and 20 minutes. Now, part B, what is the local time in Chicago if it is 5 p.m. in Seoul? So now we get on to the time differences. So again, setting it up how I did the last question. So if Seoul is to the east, I'm going to write Seoul over here. And Chicago will be here. And I just worked out the difference is 14 hours, 20 minutes. Okay, so what does the question ask me now? What is the local time in Chicago if it's 5 p.m. in Seoul? So if I put 5 p.m. under Seoul, so because I'm going to the left, I'm going to have to subtract. So one method is to convert the 5 p.m. into 24-hour time if you'd like. So that would make that 1700 hours in 24-hour time. So then we're subtracting 14 hours and 20 minutes. And you get your answer to be 2 hours, so 2:40. And it's going to be AM. Okay, so there's lots of different ways you can work out that. Is the ways to subtract 14 hours, 20 minutes from the 5 p.m. It's up to you. So the next part of the question is about looking at travel. So a flight leaves Seoul 5 p.m. and flies non-stop to Chicago after being 14 hours in the air. What is the time the flight arrives in Chicago? So the way to work that out is to start here, because this is the time in Chicago when the plane left Seoul. And so we just need to add the 14 hours of travel onto that. So it's going to be part C. It's going to be that 2:40 a.m. plus the 14 hours of travel, which will be 16 hours in 24-hour time, and then you can convert that to 4:40, and remembering it would be PM, wouldn't it? So firstly you had to work out the angular distance between the longitudes, then you had to work out the time difference that you did in part A, then you worked out the time difference when you got on the plane, that was part B, and then you added the travel time. So that question has scaffolded it out to you, but you could be asked this whole question in one go and you'd have to know to do those steps.